who am I? Why am I here? Why do you care? I'm Dennis Labossiere. I'm a director within KPMG Cyber Threat Management Practice, focusing on digital forensics, incident response, security operations, threat hunting, detection engineering. Really what I want you to get from this slide is that I'm a husband, I'm a father, and I am a lover of glamping, which is glamour camping, where I have electricity and water. Don't stick me in the woods with a tent. With them, what's in it for me? We all have something to learn, as Tony's talk kind of rolled into this one. I feel like this was done on purpose by the SANS team, but we all have something to learn, whether it be a new defensive measure, an analytic technique, finding out a new data source. This is also a reminder that you should be leveraging all available telemetry. Just because your incident, you were brought in to investigate something that happened on an endpoint, doesn't mean that incident didn't start in the cloud or start somewhere else, or vice versa. If you're brought in to investigate something on the Microsoft side or GCP or AWS, that doesn't mean there's not a way to pivot to an endpoint. So just use all available telemetry. This case is a DFIR case study, so we are going to talk about a lesson or a story from the trenches. And as I said, detection engineering. Maybe we can come up with a couple of new analytics or new detection techniques based on this talk, or someone can expand upon this research, because I'll put some limitations in here on the next slide or two, and someone can expand upon this and really be able to uncover some new techniques or detections based on this. So caveats, again, as I said, I built a test environment, even though this is based on a real world case study. It contained one Windows 10 virtual desktop, which was joined to Microsoft Entra ID and managed by Intune. I used free trials. And what I did not do, unfortunately and sadly, was enable PowerShell auditing. I didn't have any third-party integrations or EDRs, and I didn't forward any logs to a SIM or a data lake. Just was outside of the case in my point of doing this recreation. So for the agenda, I'm going to provide, and I believe in tell you what I'm going to tell you, and tell me what you told me. Someone said that to me at B-Sides a couple years ago, and I've loved it ever since. And I think that person's in this room, and they will be speaking in a few presentations today. But I'm going to provide a brief background on a real-world case that inspired this research. I'm going to baseline Microsoft Intune with you all using a newly established testing domain. I'm going to describe to you the methodology and available telemetry so you can perform something similar, or if you need to, you'll have the ability to go back on. We'll recreate an attack that occurred within a lab environment. We'll forensically analyze that, and I will share the research at the end of the presentation. I will list all the tools, and we'll have a good time. So that said, this incident occurred at approximately 33 UTC on Jan 10, 2023. KPMG responded to an incident where a remote attacker successfully gained unauthorized access to our client's Azure tenant. And as Tony had talked about, MutaLibra, Scattered Spider, Octotempest, whatever you want to call them these days, that was a threat actor we were dealing with. So upon initial investigation, it was discovered that a remote attacker attained access to a highly privileged account, so global admin account within our clients and Microsoft environment. And about 3 days later, analysis indicated that a script within Microsoft Intune named Teams Firewall Updater was modified by the remote attacker. This Intune script runs a PowerShell script down on the endpoint, and that PowerShell script name was Update Teams Firewall Rules. So you can imagine what the client was trying to do with this Intune script. The question is, why? What was modified? All right. So if this script was supposed to be updating the firewall rule to allow Teams access, why did the attacker pick this one, and what did they change? So that's what. That's the background we have, and that's the investigation we're going to be walking through. So in order to understand evil, you have to know normal, right? This is the famous SANS slogan. So we're going to baseline a brand new Intune environment. And if you have Intune or are using Intune today, you should baseline that and understand what is normal in your environment to then be able to find evil. Do you know when a script is modified, who modified it, and what was modified? So first things first, Setting up the Azure tenant, you can see here that I've set up a testing lab environment. I have my tenant ID. We're going to be using that for the Graph API to do a lot of programmatic API calls. So I need the tenant ID. I also need to create an enterprise application to leverage the Graph API, and I need its application ID. I also need it to have a secret, and I need that secret value to pass and authenticate for the Graph API so that I can obtain information from the Graph API. All right, and then you can see here that I have a user, Dennis Labossiere. I have my object ID that will come into play later. You don't have to memorize that, but know that that object ID is going to come into play later. All right, so when you set up Intune, by default, it does not have any pre-existing scripts, at least in my testing. I created 2 scripts, very benign. What they did was they create a directory on each user's endpoint on that Windows 10 VM named test, right? So C users, user desktop, and it creates a folder called test. That's all that script does. Very simple, easy to see the results when you do that. When setting up the script, you can see kind of on the right side of the screen, you get certain properties that are going to matter to us later on, right? The name of the Intune script, the name of the PowerShell script, and then some of the groups that it's impacted. So included groups or excluded, so you can know already who is going to be impacted if this were to be modified. I have an included group, so anyone in that group would receive this update. The other important thing to note in that URL is your script ID. Aside from the Graph API, that's the only way to know your script ID, that GUID. That's your unique identifier for each of these Intune scripts. So that's important to note as well, and I'll show that later on. So as I mentioned, going through the Graph API, sending a post to that URL with your tenant ID, get your bearer token so it can authenticate, and then you can then go make additional posts or gets to the Graph API. And then again, everything I mentioned, needing the client ID, the secret, your tenant ID, all establishing the baseline to get your bearer token. This bearer token doesn't live anymore, but for the sake of security practices, it's all been redacted. But you can see once you successfully authenticate, you do get your bearer token, which will then be used for further authentication and actions against the Graph API. Right, so I mentioned baselining Intune. Obviously, aside from seeing what's happening in Intune itself through the web UI, you can get that information programmatically with the Graph API. Using the device management scripts API endpoint, you can obtain the scripts detail. And I don't expect anyone to see that, so I'll blow it up here a little bit. What we're looking at, again, script ID, the description, your timestamps, obviously always important. And then you can see that this information does match back to the UI, depending on your time zone settings. The API is in UTC, and for me, living in New York, my time zone in the web UI was Eastern time, and in February, so Eastern Standard Time. And you can see how that aligns with the web UI versus the API. The information is all the same, just obviously displayed a little differently. So now that we have an idea of what we have in terms of scripts, right? I said I had 2 scripts. I want to go get information on that script, the underlying PowerShell, right? The previous call here, trying to go back, the previous call here just gives me the high level information, script name, ID, creation, if it was modified, and what the underlying PowerShell script name is. So test new dir.ps1. But what does that ps1 file do? In order to get that, you have to run another call, again, to the same endpoint, but now pass that specific script ID out to that API endpoint. And when you do, you obtain additional information about that script, as well as the encoded, base64 encoded contents of the PowerShell script. Now, as we've heard from some other talks, base64 encoding, it's not that hard to decipher, right, to decode. People have their own methods with PowerShell or Python. In this case, just throw it into CyberChef, right? Tell it to from base64. And as I mentioned, all it's doing, creating a new directory, on the desktop of a user on the machine named test. So what that looks like I said, very easy to see on the endpoint. So I know that the policy was set up correctly. I know it pushed to the endpoint correctly. And I know that it worked because I can see the results clear as day. And down at the bottom of the screen, preview of things to come in the next few slides. But there's a lot of forensic artifacts already being created on that Windows endpoint, let alone what's happening in Azure and Intune. So we'll jump into forensic analysis, but right before we do, when I was building this talk and kind of talking to some of my peers that were on the case or who weren't on the case, but know Azure or Intune, and they're like, what happens if the script's modified? Does the modification, does like the modification change the script ID? Does it change, you know, the parameters or properties? And realistically, what you would expect when a script is modified happens. The modification date obviously gets changed or assigned if it was only created and not changed. The script ID does not change. That kind of makes sense, right? You're not actually creating a new script. You're just modifying the one that existed, so the GUID's going to stay the same. So yeah, what you would expect when a modification occurs would occur. And here, you know, this is again just going through the API to say, okay, I modified the script, or the attacker modified the script. We should see that the base64 content had changed because it was modified. So it shouldn't look the same. And in this case, the base64 content is different than, or this is the original script. And then in the base64, there's a lot more data, right? More values in that base64 encoding. So clearly we can tell that the script's probably a lot larger than what the original one was. We can also see the modification time has been updated. So again, not hard to decipher or decode what happened here. Throw it in the cyber chef, and we can see here that the threat actor, aka me in the test environment, went out, called to AnyDesk, downloaded AnyDesk, ran AnyDesk, and that's the new script, right? Started the process. So again, very simple to see on the endpoint, right? I know the script worked. I know the modification worked because not only did AnyDesk get downloaded as a.exe, also very suspicious, but the application had been started and is running in the foreground, right? So again, more forensic artifacts being created here just by modifying a script and having it being pushed to the endpoint. And another prelude to something to happen in a few more slides is this policy hash you'll get in the logs. We'll talk about that here in a second, but just little snippets, right? Little nuggets to remember as we move forward with the content. So forensic analysis, right? Recapping what we've done so far is set up an environment, created benign Intune scripts that did something super generic, but was easily recognizable in the endpoint, modified that script to do something, again, noticeable on the endpoint, but nefarious in a way where why would someone be, you know, using PowerShell to download AnyDesk? Why wouldn't the user just download AnyDesk themselves? You know, things of that nature. So one of the first places to kind of look for file creation events, if you're unfamiliar with digital forensics, or if you are, again, just all available telemetry here, is timelining activity on the host, right? We have the modification time of the script. So why don't we start, you know, maybe 20 minutes before and run it, you know, 30 minutes after and see what happened on the machine at that point. In this case, with Intune, and we'll get into this in a little bit, they actually create and then relatively delete very quickly these 4 different files: a .ps1, a .timeout, a .error, and a .output file. And you can see that with the journal, the creation and the deletion are happening in less than a second. Now, these files, in my opinion, and in my research, seem to be debug files. So they're never really intended to stay on the system, right? The script runs, it has a write to these files, and when the script stops running and its execution is complete, those files are then flushed from the system, and we can see that here. Now, you're only going to see the file and deletion, or the creation and the deletion, with the journal. If we go into the MFT, you don't see them at all, right? And again, that makes sense. They're short-lived. They're flushed from the system. But what we do get is sort of what happened after the fact, which is now the creation of the AnyDesk file, a.exe, and everything that AnyDesk is doing after, because I started the process. So we're getting the creation of its own internal configuration files, its trace log files, things that we would care about if a session was truly established. What we don't get, again, as I mentioned, are those timeout, error, output, PS1 file, but we also get file sizes. So we can use the file size to compare against a legitimate version of AnyDesk, right? If we go and download AnyDesk on ourselves, we can compare that file size to what we're seeing here to determine if this was a modified version of AnyDesk or if it's the legitimate version of AnyDesk. Granted, the URL did reach out to the real AnyDesk domain, but had that been different, we could be able to determine if it was still a true AnyDesk or a modified version. And then because PowerShell ran, right, the underlying portion of Intune is running a PowerShell script on the endpoint, we should be able to determine in the PowerShell event logs that PowerShell ran and did something. So in this case, we can see that PowerShell started, right, and then the command had gone through its flow. And as I mentioned, I didn't enable the logging. Had I, we probably would have had the 4104 event ID with the script block. But what we can see here on screen is that PowerShell is running execution policy bypass, which is usually something you should flag on, but Microsoft's doing that on themselves for their own Intune. And it's running in this file, right, from C programs, x86, Microsoft Intune management extension. Note that for later, probably a place we want to look for. Policies, scripts, and then there's a GUID / another GUID, and then .ps1. So probably of interest are those GUIDs, right? What do those GUIDs tie back to? Anything that we've seen before. Also, that directory is probably a place of note that we want to look at. What else is in there? Where else does Intune create data on the endpoint? All right. The other place, aside from just event logs or the journals and MFT, is the registry. And as I mentioned, there was an Intune policy hash. And you can see here in using Zimmerman's Registry Explorer, there's a policy hash value in this registry key. And again, there's a GUID and a GUID. The first GUID is my user ID from Azure. The second GUID is the script ID from Intune. So you can tell the user responsible for creating the script, maybe not the user responsible for running it, but whoever created that Intune policy, and then you have the script ID to fall back on, right? And if it was created or modified, you have that time, right? Last updated could be the creation time if it was never modified, or it'd be the modification time if it was, as well as some full-on information down in the value of in the registry, right? In the type viewer, you can see some clear text information happening, right? Where it looks to be like the standard output from the command process, where it was to create the desktop or create the new item on the desktop, and you're seeing the standard out full on in the registry. Now that was a test script. If we look at one that was modified, the policy hash stayed the same. Your modification time gets updated. And this is a different script because note the different GUID here at the bottom. What we're not seeing in this one is any content from standard out. This is the script that downloaded AnyDesk. And the reason why you're not seeing content to standard out is there was no content to standard output, right? It went and invoked the web request, download the binary, rename the binary, started the process. There is no output, right? But when you go and create a new directory, you get an output that says, hey, I created the directory at this location. It's this file size, it has this name. We're not seeing that here because there is no standard out. And as I mentioned, Intune does have its own logging on the forensic endpoint. And as mentioned too, there's two locations because Microsoft. Program files x86, Microsoft Intune management extension, and then put that in program data and just squish it all together without spaces. So in your x86 Intune extension, you have the policy scripts, and then you have policies results. The scripts, as you remember, or maybe you don't, that's where the PS1 file gets ran from. And then the results are the error, timeout, and output file. But again, those are created and deleted very quickly. So likely, if you go look at these locations, they'll be blank, right? No values, they'll be empty. Instead, go to program data, go to your management Intune extension logs directory, and then there's going to be a number of log files in there. But the two that we care about are agent executor and then Intune management extension, both log files. And in my testing here, the agent executor, that's the log that does appear to save the clear text data from standard output into the log, as well as some other data, and we'll get into that. Whereas Intune management extension seems to be the content of the script that was ran. And again, we'll get into that. So agent executor, this is the log file opened up in, I think it's VS Code, just to view it and have some of the color coordinations. And you'll see here the user object ID, right, that GUID, so scripts / the user GUID / script ID .ps1, and we get a bunch of timestamps in here, valuable information from this log file. One being the timestamp, the user ID, the script ID, and then as I mentioned, you'll get the full standard out stored in this log. All right, and then with the Intune management extension log, again, you get the same information, the user ID, the script ID, instead of being separated by a /, it's an underscore. And you'll see the 4 files that we've talked about previously, the PS1 timeout error output, all being recorded and with timestamps, as well as down below, the policy ID or policy hash, and then the full policy body is the full script content, right? When we modified the script to download from AnyDesk and rename it, then invoke the web request and all of that, you're seeing all that content here written to this log. So valuable forensic information happening, not just with processes or files being created and deleted or running on the endpoint, but logging in terms of telemetry to tell you, hey, something's happening with Intune, something's happening in Azure that you might want to go look into further, not just here on this system. All right. And as I mentioned, let's move away from the endpoint and talk about what's happening in Azure. What is Azure seeing, or what is Intune seeing in terms of logging for the activity that we've seen? And I'll backstep a little bit to say, when we had this investigation, Scattered Sputter came in, SIM swapped the global admin like they typically do, did their thing in Azure, used single sign-on to spread through SaaS applications. And then, a couple of days later, we were dealing with the ransomware, and it was like, how did they get from Azure to on-prem, right? And that's where the investigation led us to Intune, because these systems that we were looking at as kind of being like the point of ransomware, the point of boom to the left of, we're like our patient zeros, and our client was running EDR-A, right? I won't name them, but they were running EDR-A. And the attacker used Intune instead of downloading AnyDesk, they used EDR-B. Then they connected through that console into as a backdoor using EDR-B, and then created their malware and different backdoors and all their tooling. So we're sitting there like, okay, well, how did they get that EDR deployed? That's what led us to Intune, because of those logs and these files being created. We worked our way back into Intune and said, okay, hey, this script here appeared to be modified at that same time or a couple hours before the EDR, the second EDR got deployed to the system. So it's like, okay, so they went from cloud to on-prem, and they were sitting there like, what's the gap? How'd that happen? Well, Intune was the bridge there. So then we went back into Azure and said, okay, what are we seeing Azure or Intune logging that gets us to the point of correlating this? That's the theory, right? But how do we prove that? So what we're seeing here is your server principal login. Now, these are being generated because I was using the Graph API to make calls and kind of just do my testing and pull down data. However, because an enterprise application was registered and used, that's where the service principal is happening. So you may not see this in your environment, but it's still something to be looking for, is what applications are calling to the Graph API to get information. This is a way to go see that. And I've tried to color code as best I can things that align with one another. So anything related to the enterprise application, in this case, Intune Graph API testing, is highlighted with red. Anything related to the registered application itself is highlighted in purple. And anything related to just Graph API, because again, underlying, I'm calling the Graph API, is highlighted in that light blue. And that'll stay true moving on to this slide. And the difference here on the different sides is what's in Azure UI, like in portal.azure.com, versus what's available from the Graph API. What can you get from the audit log itself? And again, the information is pretty much in parallel and lockstep. Some of the wording may change just a little bit, but realistically, they're the same information. So again, trying to just color code you and orient you on the slide, right? Anything in light blue is related to the Graph API. Anything in red is related to the actual enterprise application used to call the API or Graph API, and anything in purple is related to the kind of the secrets for the actual application. All right, so going back to that question of what happens to modified scripts, if user B, right, were to come in and modify a script created by user A, the audit log will show that, right? And this is now specifically the Intune audit log. It will show you that user B, and I'll highlight it here, now test user at whatever is user B. So test user has modified this script that user A, this guy right here, created and did everything. Still me, by the way, just changed to test user, but going back. So if you're looking at the Intune audit logs, patch device management is how Intune denotes a script was audited or modified. So calling so down here, right, send a get to device management audit logs. That's how you pull the audit log through the Graph API. And then you want to look for the device configuration category. And I'll move it to this slide so it's a little bigger. So you can see that I set a filter category equal to device configuration. And now I can see anything related to the modification. And the display name is patch device management script. That denotes a modification. And I can see who modified it and their user ID. Now, I'll ask a question here. And if user B modifies the script and then goes and runs it, is their user object ID going to be shown when the script executes? And the answer, not that it's displayed on this slide, but the answer is no. It'll still show as user A. User A created the script. User B modified it and then kind of pushed it out, but it still would look as if user A did that. So that's something to keep in mind too, right? As examiners, is we can't really always tie who the person behind the keyboard was to events. And in this case, the audit log doesn't really help you with that because the object ID ties back to the creator of the script and policy and not actually the executor of. So again, this is just showing that script B was modified by user B, so the script ID stays the same. The display name of this hadn't changed. The script content changed. The modification got updated, but realistically, nothing else had been altered. And here we go, just decoding it again real quick. So all this one did is after modifying the script was to just get the content of a.exe. So Intune logging again, past device management script denotes a modification. The UPN or your user principal name is the user that performed the modification. Your object ID, in this case, is the same as the script ID. Again, just different terminologies being used across different logs, unfortunately. And then just the difference between what you would see in the UI versus what you would see if you pulled it down, JSON through the Graph API. And here's, again, agent executor showing you the full content of standard out because that previous command of get content of a.exe writes data to standard out. So the agent executor log is showing you the contents of standard out. So, you don't have to go and maybe recreate this in a lab to then say, oh, hey, what did that script, like, what did the results look like? if there's an output to send it out, it'll be recorded in this log. All right, and as promised, the tools used. So I used our proprietary KPMG digital responder, which is our forensic triage collection tool. That's how I obtained the forensic image of the VM and was able to get the journal and the MFT, the PowerShell, all that stuff in our pretty timeline view. I used a local copy of CyberChef at the time of the creation of the presentation was 10.5.2. I used Zimmerman's Registry Explorer. That's how I was showing you all that data in the registry. And then I actually did create a script to go and help you pull Intune data from the Graph API via PowerShell. So that's up on my GitLab or my GitHub. And I created a Registry Explorer bookmark for you to use and import into Registry Explorer so you can quickly get to the Intune data and don't have to sit there and figure out where that is. That bookmark will be there. And then the other resources leverage, obviously being the Azure portal, the Intune portal, and then all the Graph API calls are down here as well, because I also believe in transparency and not keeping things for myself. So you don't have to go back to all the slides and try to figure out what the API calls were from screenshots. They're all there. And then the research here. Obviously, as Tony mentioned, he wasn't the one to reinvent the wheel about how to think about a DFIR analyst. I'm not the one to reinvent the wheel about how to do analysis with Intune. I just think that some of the previous write-ups didn't go into the exact depth or focused more on what could exist and rather than showing you what does exist and how to get to that. And as mentioned, I didn't necessarily have any data connections, and I didn't send any of these logs to Sentinel or a different data lake. I didn't have an EDR to see what that would look like. And I don't think any of these folks here did either, but these were some of the researchers and data points that I looked at in my research when doing the investigation initially, and then when building the talk to leverage upon. And I think, again, as a community, we can build upon this, and maybe I'm featured in someone else's talk as their inspiration or research. So in summary, right, tell me what you told me, or tell me what you're going to tell me what you told me, or tell me and then tell me what you told me, right? So wrap it up. I did provide a brief background of the investigation. I did detail how to baseline an Intune environment, how to pull information to the Graph API, how to decode information with CyberChef and base64 encoded PowerShell. We analyzed forensic artifacts, including the journal, MFT, Windows event logs, registry hives, specific Intune logging, Azure data, including sign-in logs and the Intune audit logs, detailing the connection of how someone can move from cloud to on-prem, provided the list of tools for the research, and then, tools for analysis, and then provided the research as well. I have a question slide, I have the obligatory thank yous, and then contact, so.